Okay, welcome back, AAG students. Right now, we're going to take our time and we're going to find the area of the segment of a circle. So what is that? Find the area of the segment at the right. So we're going to end up shading it in here, but just to be clear, the segment of the circle is the shaded region bounded by arc BC, so this kind of curved length right here, and segment BC. Now, I don't have it shaded in yet, but I will in a minute. But here's segment BC, here's arc BC. So it's just this little kind of half of a football shape right here. So they give us some information, right? We've picked 13 meters as our radius, and they've given us the fact that the measure of major arc BDC is 296. Now let's remember, the arc measure is the same as the central angle measure. So major arc BDC is the long way around, right? It's a long cut, not the shortcut. So if that's 296 degrees, then that means that's the larger angle out here. So in order to find this angle measure here, what we're going to do, or at least to find the arc measure here from B to C, we'll take 360 and subtract 296, right? Which would give us 64. So not only is the measure of arc BC out here 64 degrees, but the central angle is as well. So we're going to need that in a few minutes, okay? So basically I have a radius and I have a central angle measure. Our goal is to find this region out here. I'm just going to lightly shade it for a second, but you'll see why. Okay, so I think we have enough information here. So here's what we're going to do. I'm going to take my highlighter, okay, and I'm going to shade in the sector. Okay, so I know this is too much information. This is too much area because all we want is this little kind of half a football shape, like I said. So I'm going to just go through the motions here. I want you to see if you can follow with me. Step one, find the area of the whole sector, this whole shaded region. So after our work this week, I'm going to write down my formula. Theta is to 360 as sector area is to pi r squared. Now, I've been saying this a while. I'll say it one more time, right? Part of the degrees is to all of the degrees as part of the area is to all of the area. Okay, part is to whole as part is to whole. So let me start filling in my information here. So my central angle, my theta, is going to be 64 degrees. So 64 out of 360 equals, I want the sector area, I don't know it right now, but then it's going to be pi times radius squared. Now the radius is 13, right? And I know that 13 squared is 169. So now I have part of the degrees is to all of the degrees as part of the area is to all of it. Now, I do want to simplify this, right? And if you have the capability at home, you can take 64 divided by 360, math, enter, enter, right? And I get 8/45, just a nice little shortcut. Okay, so I'm going to have 8/45 equals S over 169. Almost wrote 14 squared. 169 pi. All right, now I'm going to cross multiply, and I'm going to get 45S equals. Now, this is going to be an approximation, so I'm just going to take 8 times 169 pi, right? So I'm going to clear out my stuff here. I'm going to have 8 times 169 pi, okay? Try to use the pi button so you have as many decimals as possible. If not, I would try to use maybe, 3.14159, just to be a little more accurate. All right, I'm going to hit enter. I'm going to get a little over 4,000, so I'm going to have 4,247 about 0.43, but of course I'm going to let my calculator remember all the decimals, and I'm going to divide by 45. Okay, so our sector area is approximately, let's divide by 45, oops, approximately 94 let's call it 94.39. 94.39, and that's going to be meters squared. Okay, so let me back up a step here, right? Now, we only wanted to find the area of this little section here. So obviously, this is too much. So my question to you is, what should we remove? Well, think about it. If we remove this triangle area, it'll leave just the area of this little football shape, okay? The segment. So what I'm going to do right now is I'm going to go shade in just the segment area we're trying to find. Okay, so if you notice, in my little checklist here, right? Step 2 says to find the area of the triangle. All right, and then finally what we're going to do is just simply take the larger area, right? All of that sector, subtract the triangle, and it'll leave our segment. Okay, but that's going to remind me to double check and make sure my calculator is set to degrees, hint, hint, right? Because we're going to need to use a little trigonometry here. So what I'd like to do is, and you could draw it right on your figure, but I just kind of drew the triangle down here just a little bit more clearly. Now let's remember something here. Using the definition of a circle, we should know that all radii are the same length. So this triangle ACB, which I have redrawn down here, is isosceles. So if angle A is 64, right? So let's remember, right? We could take 180 minus 64, right? Which is 116 degrees left over, split equally between these two angles here, right? So I'm going to have 58 degrees each. 58, 58. And now as I draw my height, which would be here, right? I'm just going to draw it down here. Okay, as I draw my height, I now create my right triangles. What do you think happened to 64 degrees, which was here at angle A? Sure, it's going to be bisected. So that's now 32 degrees each. All right, guys, so now this brings us back to our trigonometry chapter. I'm going to call, I don't know, I guess I'll just call that A, and I'll call that B, or whichever variables you'd like. But let's be careful. Remember, the base is going to be two of those B's. Okay, so what I'm going to do here is I'm going to, oh, I forgot my lengths. Sorry, we're going to need some lengths here, right? AB is 13 meters, and so is AC. All right, so the first thing I'm going to do is I'm going to calculate the height of the triangle. So I'm going to choose to use 58 degrees, right? Height is opposite. 13 is the hypotenuse. I'm going to use sine. So now I'll have sine of 58 degrees equals A over 13. All right, my variable's up in the numerator, right? We cross multiply. I'm going to get A equals 13 sine 58 degrees. Okay, calculator's set to degrees, so I'm going to go ahead and type that in. 13, make sure you can see that, 13 sine 58, and it's approximately 11.02. 11.02 meters. All right, so I have my height. So let's remember here, the goal here is to find the area of the triangle. So I'm going to need 1/2 times the base times the height. So I'm going to go ahead and write my height in my formula. Okay, so now all I need to know is the base here, and remember it's going to take two of these. But I'm still going to use 58 as my vantage point, as my reference angle. So B is down here. That's adjacent over hypotenuse. I'm going to use cosine. So cosine of 58 degrees equals B over 13. Okay. All right, again, we're going to end up with B equals 13, but this time now it's going to be 13 cosine 58. B is approximately, let's go ahead and type that in, 13 cosine 58, close it. And I'm going to get about, maybe, what's that, 6.89, I think? But before I go ahead and use that, I'm going to remember, guys, that that's only part of this base, so I'm going to double that. All right, and I'm going to write down about 13.78. So I'll even remind myself that the base is 13.78. I'm going to go ahead and put that base here in my formula. All right, believe it or not, we're almost done. This takes a little bit of time. Okay, so I'm going to clear this out. I'm going to type in the area of my triangle, 0.5 times 13.78 times 11.02. Enter. So now the area of my triangle is 75.9278. Let's call it 0.93, and I'm going to write meters squared. Okay. Now I just want you to notice something here, guys. We're just about to wrap this thing up. But the area of the sector, and I just want to remind you, includes not only the triangle, but also the segment. So the area of the sector should be larger than the area of the triangle, right? So just make sure, if you notice that doesn't happen, something went wrong. All right, I'm going to finish this up here. So the area of my segment is going to be found by taking the total area, the whole area of the sector, which was 94.39, and then I'm going to subtract the triangle. I'm going to remove the triangle away, which will leave only this segment area. Okay, so now I'm going to take 94.39 and subtract my previous answer. All right, so I'm getting approximately 18 point, I'll call it 46 meters squared. In summary, ladies and gentlemen, find your area of your sector. It's going to be too much area. Then your second step is going to be to use trigonometry to find the area of the triangle. And your third and final step would be take the larger area, which is the sector area, and subtract the smaller area of the triangle from it. I hope this helps, ladies and gentlemen. There are 3 examples on your practice questions. All right? Good luck. Let me know if you need me. Thank you.